Hi guys, and welcome to Activity 5 of the Year 8 Physical Sciences course. In this activity we're going to be looking at gravitational potential energy, or GPE. Okay, so firstly let's just discuss what gravitational potential energy is. Well, basically it's the energy which is given to an object when it is raised above the ground. Now, the word potential means that it's stored. The energy is not released until the object has been released from its height and drops down to Earth. Now, there's a variety of different variables which will control the size of the gravitational potential energy. And these variables include the mass, which is given the symbol m, which is always measured in kilograms, the acceleration due to gravity, which on the planet Earth is always going to be 10 meters per second, and the height h in meters, m. Now, with respect to acceleration, obviously if we go to other planets, then the gravity changes, and of course the acceleration due to gravity will change. All of the questions that you will deal with in this activity will be on Earth, and as a result g will always be 10 meters per second. So, just to recap, gravitational potential energy is the energy which is gained when you lift an object above the surface of the Earth. The higher you lift it, obviously the more energy it's got. The lower, obviously the less energy it's got. And gravity is what grabs hold of that object and pulls it down once it's been released. Okay, so how do we calculate gravitational potential energy? Well, we use the following formula. The gravitational potential energy, GPE, is measured by the mass multiplied by the acceleration due to gravity, g, and then multiplied by the height that it's raised above the surface of the planet. In this case is going to be Earth. So GPE equals mgh. Okay, so how do we use this formula? It's a lot easier than the kinetic energy that we looked at earlier in activity 4. So I'll run through it in an example, and then you'll be able to follow that example and do some exercises for yourself. Okay, so here we go. So we've got an example where we've got a girl who stands on a high diving board which is 10 meters high. If she has a mass of 55 kilograms, what is her gravitational potential energy? Okay, well the first thing we need to do is write down what we know. So we know her height. This is how high the diving board was. It's 10 meters high. We know her mass, which is 55 kilograms, and we know the gravitational acceleration is going to be 10 meters per second. So the height's in meters, so we don't have to convert. The mass is in kilograms, so we don't have to convert that. And the gravitational acceleration is the same. So we're looking at GPE. It's mass times gravity times height. Okay, so we just substitute in for those variables. So the mass is 55. The acceleration due to gravity is 10, and the height is also 10. So when we put all that together, we're going to get a GPE of 5,500 joules. Now this obviously can be converted to kilojoules, and then it would be 5.5 kilojoules if we divide by 1,000. Okay, so there's a simple example where we write down what we know: the height, the mass, the gravity. We check that the units are correct, so meters for height, kilograms for mass, and then obviously the gravity is always going to be 10 meters per second on Earth. We write down what we're trying to find, GPE, write down the equation, which is mgh. Now remember, this formula will be given to you in your assessment paper when you do your test. This formula will be there, so you don't have to remember, you just have to recognize it. Then we substitute in the variables and multiply through. Very, very easy. Okay, so here's some examples that I'd like you to have a go at. So pause the video in a second, run through the answers, and then we'll run through it together. Okay, pause it now. Okay, welcome back. So how did it go? Fairly easy? I would have thought so. The values are fairly good, so you don't have to make any changes. So let's look at the first one. We're working out the GPE of a 3 kilogram object on the planet Earth, which is 15 meters above the ground. So the fact it says it's on the planet Earth means that the acceleration due to gravity will always be 10 meters per second, as I said earlier. Okay, so let's write down what we know. Mass is 3 kilograms, height is 15 meters, Gravitational acceleration is 10 meters per second. We're finding GPE. We write down the formula, mgh, and then substitute in for mass, gravity, and height. So it's 3 times 10 times 15. Gives us 450 joules when we raise a 3 kilogram object 15 meters above the ground. How did you do? Did you get it right? Good on you. Well done. Okay, well, let's look at question 2. So we've got a person who's 73 kilos on Earth, 23 meters above the ground. So mass is 73 kilograms, height is 23 meters, gravity is 10 meters per second. All the units are fine, and we're finding GPE. We know what the formula is, mgh. Substitute in, so we get 73 for mass, multiplied by 10, which is the gravity, times 23, which is the height above the Earth, comes to 16,790 joules. Or we can rearrange that to 16.8 kilojoules, and I'm rounding up to 1 decimal place. Okay, let's try 2 more. So here's 2 more examples. Look at the question carefully, because there are some conversions that you're going to have to do. But they're very, very simple, so I'm sure you'll do fine. So pause the video now, and I'll join you in a second. Okay, welcome back. So how did you go with the conversions? I hope you noticed them. So in question 3, we're looking at the GPE of an object, 54.6 kilograms, no problem there, and it's 23, now notice it says centimeters above the Earth. Now if you put in meters, then you're going to get the answer wrong. It's centimeters, so we need to convert to meters first. So you can see we write down what we know. Mass is 54.6 kilograms, no problem there. Height is 23 centimeters. I'm going to have to change that into meters by dividing by 100. Gravity acceleration is 10 meters per second, and I'm finding the GPE. So the first thing that we always do is make sure we do the conversion. So it's 23 centimeters divided by 100 will give me what 23 centimeters is in meters, which is 0.23 meters. Once I've done that, I've got my mass in kilograms, my height in meters, everything's good. I substitute into mgh, so I get 54.6 times 10, which is acceleration due to gravity on Earth, times 0.23, which is my height in meters. It comes to 125.6 joules. I hope you got that right. Not too difficult, but sometimes you're going to have to look out for those conversions. Okay, let's look at question 4. Did you notice the problem there? Yeah, it's that 700 grams. We've got to convert that into kilograms. So, we've got 700 grams, we've got 8 kilometers, that's also a problem, and we've got G being 10 meters per second, that's fine, and we're looking for GPE. So we're going to have to do 2 conversions here. One for the mass, and one for the height. We've got to convert the mass into kilograms. We've got to turn the height into meters, not kilometers. So the first one, the mass, it's 700 grams. So I've got to divide that by 1,000 to find what it is in kilograms. So it's 700 divided by 1,000, which is 0.7 kilograms. For the height, I've got to convert 8 kilometers into meters. So I've got to multiply by 1,000 because there are 1,000 meters in a kilometer. So it's 8 times 1,000 gives me 8,000 meters. Now I've got my mass in kilograms, I've got my height in meters, my acceleration due to gravity is always 10 meters per second on Earth, so I just substitute into my formula mgh. So I end up with 0.7, which is the mass, multiplied by the acceleration due to gravity on Earth, which is 10, times the height, which is 8,000 meters, so I get 56,000 joules. Well, this can be converted into 56 kilojoules. Okay, so I hope you found those exercises useful. There will be another exercise for you to go through where you will convert GPE or calculate GPE when you're given the mass and the heights on the planet Earth. And then there'll be some conversions into kilojoules, just like we did with the kinetic energy. So I hope you found that useful, and join me again in the next activity. Thank you for watching.